All right, now we're going to move on to our other topic for tonight, which is called CPCTC. And this is really, I think, section 4-4 from our unit. So I'm going to start with some general notes, and then really CPCTC is all about proofs. So we're going to do a lot of proofs tonight. And I hope by the end you guys will be saying, wow, Miss Jones, I didn't know proofs could be so much fun. So let's start out with kind of defining what CPCTC stands for and how it relates to the topics we've been covering on triangle congruency. So if we first look at CPCTC, and we're just going to take some general notes. So we've really been using 4 different methods for finding triangles congruent. Side, 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 angle, side, angle, and angle, angle, side. And as I've been telling you guys, these I call them 4 shortcuts. They're really postulates and theorems. But basically, what they allow us to do is to focus on just 3 parts of the triangle. And once we prove that 3 parts of the triangle in some combination of angles and sides are congruent, we can say that the triangles we're talking about are actually congruent. Now, once we prove that the triangles are congruent, then we know that all the corresponding sides must be congruent. And all the corresponding angles must be congruent. So, really what the term CPCTC does is summarize this fact into this little acronym. So, if we know triangles are congruent, we also know that the corresponding parts of congruent triangles are congruent. All right, now we're going to apply CPCTC to some proofs. So, we're going to use flow proofs. And we're going to use the congruent theorems we studied, the 4 we've talked about, that really only prove triangles are congruent only using 3 parts. And once we prove that the triangles are congruent, we're going to use CPCTC to help us draw a further conclusion. And we'd like for your answers to be in flow proofs. Mrs. Jones hates flow proofs. One, because I'm really not that neat of a writer, and so it's hard for me to stay organized and neat in a flow-proof format. But I'm going to really try because you guys need to know what a flow proof looks like also. So bear with me if I get a little messy. I'm going to use a separate sheet of paper instead of writing on the document because I know I can't keep it neat enough in that small space. So, we're going to start out with the first proof. And remember, as I'm always telling you guys, when you're working on a proof, you need to know where you're going before you start writing. Don't start writing until you know your directions. It's just like my example. If you're driving to First Colony Mall, you want to know where you're going, which route you're going to take from Travis before you get on the road. Okay? So that also applies to proofs. So first we look at what's given and try to flesh it out onto the diagram. So we got BD is perpendicular to AC. Okay, so we know those are two 90-degree angles. We know it gives us that D is the midpoint of AC. So that means these two sides are congruent. Okay, so now I'm trying to think. I want to prove that angle A is congruent to angle C. And what I start thinking is, if I could prove that these two triangles are congruent, then I could prove by CPCTC that these two angles are congruent. All right, so let's get started. So first I'm going to start in my flow proof with what's given. So what is given to me, I'm going to put in my little box, is that BD is perpendicular to AC. And from that, I know that angle BDA is equal to 90 degrees. And I also know from that angle BDC is equal to 90 degrees. Okay? And from these two, and why do I know that? That's the definition of perpendicular lines. Then from these two, I know that angle BDA is congruent to angle BDC. Why? Because of the transitive property. Right? It's A is equal to B, and B is equal to C, then A has to equal C. Okay, so I fleshed out that these two angles are congruent. Now, what's also given to me, and I forgot to write the word given up here, so let me add that back. What's also given to me is that D is the midpoint of AC. That was given. And from there I know that AD is congruent to DC. How do I know that? Definition of a midpoint. Okay, so now I've got two sides that are congruent. I've got an angle, two angles that are congruent. And remember, I have that third side, the shared BD. So I should be able to say that BD is congruent to BD. And why is that? Because of the reflexive property. Okay, so now I've got a side here, angle here, and another side here. So I've got side, angle, side congruence when I bring all three of these together. So I can say the triangle ABD is congruent to triangle CBD. Why? Because of side, angle, side. Now, from there, I'm not done. Because even though I've proven that these two triangles are congruent, I need to go one more step to prove that these two angles are congruent. And that's where the corresponding parts of congruent triangles are congruent is going to come in. So I'm going to take that next step and say that angle A is congruent to angle C. And why is that? Because of CPCTC. So now I've concluded my proof using a new method for us that I really haven't used previously, the flow proof. All right, let's go on to the next problem, number 2 on the page. And let's look at number 2. And again, we're going to start at the same place. We're going to look at what's given to us, and we're going to figure out our path. And we ultimately know we want to get to being able to prove that EG is congruent to MP. And once again, our strategy is going to be that if I can prove that this triangle is congruent to this triangle, then I'll be able to prove that these two sides are congruent. So let's drop on what we know. We know that angle E is congruent to angle P. And we know that K is the midpoint of EP. So that would mean that this side is going to have to be congruent to this side. So I've got an angle over here that's congruent. I've got sides that are congruent. If I had another angle, I would be good. And what I realized is I've got a vertical angle here. So these two angles ultimately are going to have to be congruent. So with angle, side, angle, I'll be able to prove these two triangles congruent. Once I prove the triangles congruent, I can move forward and prove that these two sides are congruent. So let's move on to our flow proof. So I'm going to start with what's given once again. So angle E is congruent to angle P. Why? Because it's given. And then I can say K is the midpoint of EP. Why? Because that's given also. So also, I know that if this is the midpoint of EP, I can go further and I can say that EK has to be congruent to KP. Why? Definition of a midpoint. And I also can say down here that angle EKG, this angle right here, is congruent to angle MKP. And why are these two angles congruent? Vertical angles. All right, so I've got this angle congruent, I've got a side congruent, and I've got another pair of angles congruent. And the side is the included side, or the side between the two angles. So I'm going to move forward from here in my flow proof, and I'm going to say the triangle EKG is congruent to triangle PKM by angle, side, angle. Congruency. So now from there, I can go one more step, because remember, I'm not done. I want to be able to say that this side, EG, is congruent to this side, MP, and I can do that by using CPCTC. Corresponding parts of congruent triangles are congruent.